OCR GCSE Computer Science, Episode 10, Hexadecimal. Let's look at the video contents. In this video, we're going to look at quite a few different things. What are hexadecimal numbers? How do these hexadecimal numbers work? What does base 16 or base 10 actually mean? Converting to other units, why hexadecimal is used, and finally finishing on some exam questions. So you can use the timestamps to skip around if you wish. So far, we've looked at the two units, both denary, which is just normal counting that we use in everyday life, which is called base 10, and binary, which is what we've looked at in computing, and it's base 2. But there is one more unit that you need to know for GCSE Computer Science, and that is hexadecimal numbers. Now, hexadecimal numbers is what we call base 16, and it uses 16 different digits. So how does hexadecimal work? A single hex character can represent any number from 0 to 15, and this is denary. A single hex character requires 4 bits, a nibble, in binary. Now, from 0 to 9, the hex values are identical to normal decimal or normal denary values. So if you wanted to say what 6 would be in hexadecimal, it's just 6. But from 10 to 15, the hex values are actually alphabetical letters. So if you wanted to say what 13 is in hexadecimal, it would be D. So let's look at an example of how hexadecimals work. Convert the hex value 72 into denary. So you can't view the hex value 72 as 72. You need to split them into 7 and 2. But first, let's understand what the base 16 actually means. So base 10 we use on a day-to-day basis. Every value increases by values of 10. For example, you've got ones, tens, and hundreds. So if you wanted to say the number, as you can see, 125, the 1 represents 100, the 2 represents 20, and the 5 represents just 5. Now base 2, this increases by values of 2. So you've got, 0, and then, so you've got 1, and then 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on. So each value increases by a value of 2. So now let's look at base 16, hexadecimal. So in base 16, everything increases by values of 16, which means to get from the one on the right-hand side to the left-hand side, you have to multiply by 16. So 1 times 16 is 16. 16 times 16 is 256. So now we've understood what exactly this base 16 means, we can now convert the hex value 72 into denary. So you want to take each value of the hex and place it in the table. So 72 would be 7, 2. If it was 702, for example, then the 7 would go in the 256 column, the 0 would go in the 16, and the 2 would go in the 1 column. Now, step 3, you are going to multiply each value by the placeholder that it is in. For example, for the 2, you're going to multiply that by 1, and for the 16, you're going to multiply that by 7. Now, you've moved on to step 4, which is finally just adding each value together, and that is the equivalent denary value. So you're going to do 112 plus 2, which gives you 114. So the hex value 72 means the denary 114. Now, to convert between hexadecimal and binary, you need to remember that each hex value stands for 4 bits, a nibble. So turn each single hex digit into a nibble. For example, convert the hex value 72 into binary. Again, split up the numbers into 7 and 2, and then make them both binary numbers. So 7 would be 0, 1, 1, 1, and 2 would be 0, 0, 1, 0. Then what you're going to do to convert it between hexadecimal and binary is that you're going to then concatenate both of them together, which means just bring them together. So you've got the 7, you've got the 2, you just make it one big long binary string, and that will be your answer. And finally, you need to know, why is hexadecimal actually used? What's the purpose of it? So the reason why hexadecimal is used, because it's simpler to remember than numbers in binary, and it's also easier to convert between binary and hex values. So remember, if you wanted to say a number like 10, for example, in hexadecimal it's only the letter A, so it's much more simpler to say A than it is to say a 2-digit value. Now, due to hex numbers being shorter, there is less chance of also input errors, which is another advantage. Now, they may ask you this in the exam to answer why are hexadecimal used and why they're easier, so definitely talk about at least 2 of these 3 bullet points. Now let's look at some exam question practice. So a register in a computer contains binary digits. The contents of the register could represent a binary integer. You need to convert the binary integer to denary and then to hexadecimal. And then part B is that the contents of the register could represent the ASCII value for the single denary digit 7. Oh, okay. If you haven't watched the characters video we've already done, or we're going to be doing soon, then do not answer B. But if you have watched that, then you can answer that too. Now let's look at the answers. So the denary value is 8 and the hexadecimal is 3, 7. And for B, you can see the answers there. Here's another exam question practice. So Dheeraj identifies 3 hexadecimal numbers. Write the denary numbers for each of the 3 hexadecimal numbers. So you've got 2A, 101, and 21E. And the answers are 42, 257, and 542. Thank you so much for watching this video. If you did find it helpful, make sure to subscribe to Noble for GCSE and Noble for A-Level. Your comments are so lovely. Thank you so much for all of your support, and I wish you good luck in your exams. See you soon.